Hello everyone, my name's Louise. Thank you for joining me for today's lesson where we are going to be talking about something called the water cycle. So you might have heard of this before, maybe you've studied it a little bit at school. So it's just kind of going over the basics of this cycle and how it works in our world. So first of all, we're going to talk about water on Earth. So when the first fish crawled out of the ocean onto the land millions of years ago, the same water that you brushed your teeth with that morning, or that I'm drinking now, was in the ocean then, millions of years ago. When dinosaurs walked through lakes, feeding on plants, the water that you used to shower was part of those lakes. There's approximately the same amount of water on Earth today as there was when the Earth was formed. And the water is being continually recycled in the Earth's water cycle. So it's quite crazy to think about that the water that I'm drinking now or that I showered with is exactly the same water that dinosaurs were using. It's all just being constantly recycled. So today we're going to talk about how that water from billions of years ago has been recycled by the earth and is being used by each one of us every single day. The process of the earth recycling water is called the water cycle. And without it, nothing would grow and we would not survive. So the next thing we need to think about is something called states of matter. So there are 3 different states of matter we need to know about: solid, liquid, and gas. These are the 3 states that anything on Earth can be in. You might have heard of these before. If you're not really sure about what they are, don't worry, this is all that you need to know today. That water, we can find it in 3 states. We can find it as a solid, as ice, as a liquid, as water, and as a gas, as water vapor or steam. So kind of when water boils, like when we boil our kettle, and that hot steam comes out of the top, that is water as a gas. So these are our 3 states, and as water goes through the water cycle, it changes through these 3 states, and especially through liquid and gas. Before we move on to the actual cycle, I just want to mention the sun, because even though we're going to talk about the 4 main stages of the water cycle, really the most important factor that there is in all of it is the sun. It's the engine behind the cycle, because it's what gives all of the energy into the cycle for water to go through these changes of state. So to go from a solid into a liquid, you need to heat it up. That needs energy. That needs the sun. So the sun is the powerhouse behind this whole cycle. So don't forget about that. Okay, so moving on to our 4 main stages. The first stage that we're going to talk about is evaporation or transpiration. They're kind of the same thing. I'll go through that in a minute. Then condensation, then precipitation, then accumulation. These all seem like very sciencey words, these shun words, but don't be scared of them. We're going to find out what they all mean, and you can just learn the label for that process. And just to remember, I've put them in this order, but because it is a cycle, it's continually going like this in a circle, you can put them in any order. We could start at condensation or we could start at accumulation, because one feeds back to the other. So accumulation feeds back to evaporation and transpiration. Okay? So moving on to just see a diagram of the cycle. So my face there is covering up the important powerhouse, the sun, in the top right hand corner. You can see that shining down on the sea. Just to give you a quick look at this to become familiar with it, and then we're going to come back to it later once we know what all of these scary terms mean. So first of all, we have evaporation or transpiration. These I put together because the same kind of thing is happening, but they're slightly different. So first of all, thinking about evaporation, that's our picture on the left. As the sun shines down on accumulated water, so that basically means bodies of water or any water we have anywhere on land, which is all accumulated, it's gathered together, the sun shines down on it and the water begins to heat up. And as we said before, after it heats up, whilst it's heating up, it changes state from a liquid and it turns into a gas. It turns into water vapour. The water vapour then rises into the Earth's atmosphere. So the sun shines down on the sea, for example. water from the sea evaporates, it turns into water vapour, and it goes into the atmosphere. And if you're thinking, oh, but ocean water is salty, and then the water I drink isn't salty, it's because when it evaporates like this, it leaves the salt behind. It does not take the salt with it. So it's water vapour in the Earth's atmosphere, and then the water vapour merges together to form clouds. And that is evaporation. That's our first stage. Water from the ocean or other accumulated water parts goes into clouds in the sky. Transpiration is moving to our picture on the right. This is when water evaporates from plants. It's a little bit, it sounds a bit gross, but it's a little bit like plants sweating, and it's called transpiration. So, and there are some plants that live in the desert, for example, that develop special adaptations to trap all the water inside their leaves and stop them sweating it and transpiring it out. So we can see this diagram here is quite useful. It shows us deep down in the soil there's moisture, there's water, that is our accumulated water. The plants draw it up through their roots because they need it for all the nutrients it can give them and the hydration it can give them. And then it transpires, it sweats it out of its leaves, and that water again gets evaporated and turns into water vapour in the sky. We can all easily observe water evaporating by finding a puddle near our school or near our home after it's rained. And then you'll see throughout the day, once it stopped raining, even if it's not that sunny, it still happens, that the puddle will get smaller and smaller and smaller. And that's just because the water in that puddle is not going into the ground normally. Normally, especially if it's on concrete or a hard surface, it's evaporating into the sky. And remember, solar energy is what's driving all of this, and so our evaporation is responsible for clouds and rain as part of our weather. So there we have it, stage 1 of the water cycle. Coming to stage 2, we can see we've moved on from that picture on the left. So evaporation was that first blue arrow, and now moving to our second blue arrow, condensation. So after water vapour enters the atmosphere, it begins to cool down. So it was in the ocean, the sun heats it up, it rises to the sky, and then it's not having that sun's energy heating it anymore, and up there it's a bit cooler, so it cools down. And as it cools, it condenses. That's the opposite of evaporation. Evaporation is going from liquid to gas. Condensing is going from gas to liquid. So it condenses and forms back into a liquid. Groups of water droplets come together to form clouds. So that's what clouds are. They're just groups of water droplets which have evaporated. Some are condensing, some are evaporating. And when water changes from a gas to a liquid, that process is called condensation. So condensing, condensation. Even in a cloudless and a very clear blue sky, there is still water in the atmosphere. The atmosphere acts as kind of a road for water because it moves water all around the Earth. So the water might evaporate here in the UK, and it might go into the atmosphere, and it might move over and it might turn into a cloud over America or somewhere completely different. So that's one place we can see condensation, but clouds aren't the only place to observe condensation. You can see it on a much smaller level. If, for example, on a very hot day, if you take a glass of icy cold water outside with you, you can notice that the outside of the glass will be wet. If you've ever had that before, if you picked up your glass on a hot day outside and the outside of the glass is wet, and sometimes even you drink it and it drips water on you and it's a bit annoying. It's not your cup leaking, I'm sure you already know that, but if you didn't know quite what was happening, it's because the water vapour in the air is hitting the side of the glass, which is very cold, it's cooling down and it's condensing into liquid, back into water on the side of your glass. So that is our next step, condensation. The third step we have is called precipitation. As more and more water condenses into that cloud, it goes back into water droplets, it's being held in the cloud becomes too heavy for the air to hold it up there. And that's when the water will fall back to earth as rain, as hail, as sleet or as snow, depending on how cold the weather is that day. So precipitation is basically just a fancy word for rain, or it can sometimes be snow or sleet or hail. It's just an all-encompassing term for ways that the water will fall back down to earth. The process is known, as we said, as precipitation, and it's really important because it allows the water in the atmosphere to return back to the Earth's surface. Without it, we wouldn't be able to have our cycle. So when the water does return to the Earth's surface, it provides water for plants and animals. For us, for example, water that doesn't get absorbed into the soil will experience an additional stage called runoff. Runoff is where water is forced by gravity to move across Earth's surface towards large water accumulations. So we're going to see that in the accumulation stage, but basically what it's saying is, if the cloud rains over the sea, great, no problem, the water's in the sea, done. If the cloud rains over a lake, same thing. What if the cloud rains, for example, on the top of a mountain? The water there is just kind of falling onto the land. It's not falling into an accumulated or group of water. So what happens then is the water that's fallen on that mountain runs down the mountain and finds its way somewhere lower down to a body of water, to a bigger accumulation of water, and that is called runoff. Okay, so the final stage of our cycle is accumulation. We've already kind of touched on this, but water accumulation refers to water that is stored on the Earth's surface. This can be in rivers, lakes, or oceans. The largest water accumulations on the Earth are in fact oceans, and they hold nearly 97% of the Earth's water. So there's only 3% of water on the Earth, including all the water we shower with, all the water we drink out of, all the water used to make clothes, food. That's 3%. But not even, because there's 97% in the ocean, and there's another 2% locked in ice caps and glaciers, so the North Pole, the South Pole, and other glaciers around the world. So that leaves just 1% of all the water on the Earth for all of humanity's needs. So all of our agriculture, our residential needs, manufacturing, community and personal needs like drinking, showering. So it's really not much. So we do need this water cycle to be working well. So all our sewage, for example, when we go to the toilet and we do a wee, that water is still part of the water cycle. It's going to be evaporated back up. All the parts which make it wee, the urea, things like that, they get left on the Earth. Don't worry, that's not coming rain back down. Just the water goes back up. So accumulation can also refer to groundwater, which is water that seeps into the Earth's surface and is absorbed by roots to help plants grow. So the most obvious version of accumulation is in the sea. We can see that's a big body of water, but there's other bodies of water, like the water which is underground, like we saw on our transpiration slide, that soil moisture zone. That's a big accumulation of water beneath the soil that plants draw on. So that's another part. And then we also have surface runoff and subsurface runoff, like you can see in this diagram. That's the runoff I've spoken about. So when we get precipitation at the top of a mountain, some of it gets absorbed into the ground, some of it stays on the top, but all of it does run off towards a bigger accumulation of water. Essentially, mostly it all gets carried back to the sea. As we said before, a lot of water, 2% of water, is stored in ice caps and glaciers. But if you've watched my video on climate change, or if you know anything about that, you'll know that that is changing because the ice caps are melting. So that is going to affect the water cycle as we know it. So there are 4 stages, and you can see them here in this diagram. So we've got transpiration coming off the plants, evaporation coming off the sea. It's then condensing, forming clouds, and when it's condensed enough, when the clouds are heavy enough, we get precipitation, it rains back down again, runoff, and then accumulation. It all gathers into big bodies, all the water, where it can go again and be evaporated or have transpiration happen once again. And this process can take a long time. It doesn't necessarily mean that water that's rained one day is immediately going to be evaporated the next day. Some of the water will stay in the system for a long time, like the water that's going through our systems to provide drinking water, to provide water in the shower. That's going to be not evaporated for a long time. So it depends where through the cycle it goes. So once the water cycle is completed once, it repeats over and over again. So we have an overview of the different stages of the cycle, but each water molecule will travel on a very unique and varied journey during its involvement in each stage of the water cycle each time. Water molecules might be kept in a container by us, maybe in the fridge. They might be drunk. They might be carried and excreted by an animal. Excreted basically means going for a wee. They might be stored by a plant. They might be used to boil pasta. Or they might stay in the ocean or in your neighbour's next door pool for ages before they evaporate and begin the next stage of the water cycle. So we know the stages, but it's very varied for each water molecule, and that is how the water cycle works. Just to show you here, a more fancy name for it is the hydrologic cycle or the hydrological cycle. It's just another way of saying the water cycle. So thank you very much for listening to me today. I hope you've enjoyed that introduction to the water cycle and that you'll go on and think about the next time you have a glass of water exactly where it's been before it come into your hands today. So thank you very much and goodbye.